Hello, my name is Shujan Singh, and this is my Columbia Maker portfolio.
2023 FRC Charged Up game, I designed a pneumatic arm that could pick up cubes and auto-orient cones to face upwards. I tested various geometric linkages and dimensions to create the final design using pneumatics and various types of box tubings. For the 2025 FRC Reefscape game, I designed a two-stage cascade elevator to score coral on various heights. First, I created an elevator prototype using 80/20 tubing. Then I 3D modeled it and constructed the final design using 2x1 aluminum box tubing and bearing sliders. Additionally, I designed a vertically mounted electrical system using sandwiched polycarb plates and threaded rivets. As a result, our robot competed in the semifinals of the Heartland Regional Competition. 2024 FTC season involved putting blocks in baskets and scoring specimens on chambers, where I designed 5 claw iterations and 6 intake iterations. My first intake design used speed servos and rubber stars to intake the block. After our first competition, we switched to a 1-servo claw design that transferred to a 3D printed claw to score in high baskets. For our third competition, I prototyped multiple servo roller intake designs to reduce driver precision during matches. To score specimens for our fifth competition, I designed an aluminum CNC arm utilizing gears, standoffs, and a rotational claw, allowing us to score without turning our robot around. By the end of the season, my team and I had designed over 3 robot iterations. The 26 FTC season is shooting balls into a goal. I designed 3 flywheel iterations and 2 intake iterations. Initially, I made a quick prototype of the intake using rubber stars, then expanded its width using larger stars on the sides and 3D printed funnel mounts to transfer the ball to the middle of the robot. I also designed a hooded shooter and added aluminum weights in the wheels to increase the moment of inertia and reduce recovery time between each ball shot into the goal. By our second competition, we were able to shoot close and far shots. I designed a turret to reduce the accuracy required from our drivers and prevent defense. Additionally, I redesigned the flywheel to have 2 motors to increase the throughput of our shooter. Our next redesign has a roller intake design and a spindexer to sort and score the balls in a certain color pattern to gain extra points. After our team won the 3rd place Inspire Award, I redesigned our intake brackets and our spindexer for our next competition. Paired with a transfer design that was created by one of my teammates, our spindexer and transfer subsystem could rapid fire at 0.8 seconds. Our team also redesigned our turret to be much more compact by solely utilizing non-flinched bearings. We also redesigned our camera mount and added another servo to the spindexer to exercise greater control of the ball. We also added wedges to the side of our intake to add greater stability and control the ball's pathway into our robot. On the screen is our 12-ball sorted autonomous thanks to our programming lead. We also had a 12-ball sorted auto from the far zone, which allowed us to have greater alliance flexibility. On the screen is our teleop. During driver practice, our robot could average roughly 32 to 38 artifacts and achieve 120 to 140 points per match, including autonomous. For the 2026 FRC Rebuilt season, I designed a 29-inch by 25-inch frame. Our team then prototyped various intake and flywheel designs, and our flywheel prototype shot roughly 30 feet and had counter rollers to reduce backspin. I then went on to design our final intake design using 1/4-inch aluminum. Thanks to one of my teammates, we were able to conduct structural pocketing to cut weight. I also designed our double flywheel design using 2 NeoVortex motors, and designed our vertical transfer system using PVC rollers and 2 installed wheels. I also designed an extending storage using 1/8 inch polycarbonate and pulleys. This led to our final robot's completion. At our first competition, many of our intake parts severely bent, so I redesigned our intake to use polycarbonate and our extending storage to use T-brackets and 1/4-inch polycarbonate and smaller slots. This led to our new robot for our second competition. Over the summer, I CAD'd a coaxial and differential swerve module drivetrain, which utilizes various types of belts and gear ratios. This drivetrain is a future upgrade to our current Mecanum drivetrain. I didn't build any of these projects alone. I'd like to thank my friends, teammates, and mentors with this montage.
Return to the Mac, get on what it is, what it does, what it is, what it isn't. Looking for a better way to get up out of bed instead of getting on the internet and checking a new hit. Me get up, first shot, come strut walking. A little bit of humble, a little bit of cautious. Somewhere between like Rocky and Cosby's for the game. Nope, y'all can't copy yet. Glad moonwalking, and this here is our party. My posse's been on Broadway, and we did it all way. Chrome music, I shed my skin and put my bones into everything I record to it. And yeah, I'm on. Let that stage light go and shine on down. Got that Bob Barker suit game and Plinko in my style. Money, stay on my craft and stick around for those pounds. But I do that to pass the torch and put on for my town. trust me. On my INDEPENDENT shit hustling. Chasing dreams since I was 14 with the 4-track bustin'. Halfway across that city with the back question. Labels out here, now they can't tell me nothing. We give that to the people, spread it across the country. Labels out here, now they can't tell me nothing. We give it to the people, spread it across the country.
Can we go back? This is the moment, tonight is the night. We'll fight till it's over, so we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Can we go back?